And this is a chapter 4, 12 and 4, and delta connected source and load. We already studied about the delta connection and the Y connection in the 3-page systems. So remember that we have a source here. We have one source and another source, and this is another source. And this voltage we call we define this is N. I will use another color. This point is N, and this terminal is connected like that, in this manner. Define this point is A, and this point is B, and this point is C. Then we define this voltage is VAN, and this voltage is VBN, and this voltage is VCN. Then we define the VAN is a kind of a maybe V 0 degree, and VBN is V minus 120, and VCN is same magnitude, and that is, we call this is the balanced source. This is the balanced source. And we can define the other terms. There's kind of a, we call this is a phase voltage. We call this is a phase voltages. And we call this is a phase voltage. And also we define the current here, here, IA, IB, IC. So this is a IA is I maybe theta. IB is the same magnitude. When the load is balanced, this is magnitude the same. The minus 112. IC is the same. The plus 120 degree in this manner. Because this is a phase current. In the case of Y connections, the current voltage is defined in this manner. But we already talked about the delta connections. Delta connection is a source, is rearranged in the shape of the delta. So we move connection. This source is connected is a Y manner. Then in the case of delta connections, we have a same source here and here and here. This is a VA, this is a VB and VC. And move this here. And make the same terminals in this manner. B and C and A. So this is a VA and VB and VC. So we call this is a shape of delta. So we define this is a delta connection. So in this case, we have, delta connection has a very special things. That is, because this is a loop, kind of a loop in the source. So there will be some current in this here. Maybe you can define the current distribution is in this manner. This is we call this is in a loop. We call this is ICIR. That means define this current is we call define circulating current. In Korean, 순환전류. So if this loop looks like that, this loop can be represented in very simply like VA, VC, VB. So when you make a loop in this manner, then VA plus VB plus VC. If balance the source, then VA plus VB plus VC is 0. So then no problem and no circulating current. But however, if source is unbalanced, for example, VA is 120 and 0 degree, VB is the same magnitude, but the phase angle is minus 121. VC is same magnitude, but this angle is plus 1 to 1 degree. Then if in this case VA plus VB plus VC is not 0, in this case we have to calculate here. The result is some kind of a minus 3.76 plus J 0.086. This is not 0. What's the meaning of that? Then this circuit can be rewrite here. How can do that? In this manner. This voltage is that values. Then what happened? This is I circulating current. Because they are very small impedance, very small impedance. So I circulating current is very huge. This makes some problem. So when you make a 3-phase, so in 3-phase generator, we does not use, in this case, we cannot make a perfect balance source. Therefore, in the generator, the delta connection is not applied. Because of these problems. So in the case of transformer, we will tell tell you, maybe we will learn about why you have to use the delta connection in the three-phase transformer. The delta connection is very great advantage in the viewpoint of the transformer. We will talk about that as in the maybe later, maybe energy conversion theory. Maybe we'll learn in the next year. But in the circuit theory, we do not talk about the why we have to use delta connections. That is related to the transformer. It's non-ideal phenomena. But anyway, the delta connection is very useful. So we'll discuss about the delta connection in this chapter. So here we will discuss about how to transform the delta to Y or Y to delta. Delta to Y or Y to delta transformation. For example, we have some source, 3-phase source in this manner. And so I have a conventional load. This is a kind of impedance here. So 3-phase impedance looks like the Y or delta. We connect in this manner. Or we have a source, but that is not Y. We can connect the load in this manner. So in the viewpoint of the source, this is a load here. So this is a load. So in the viewpoint of the source, this is impedance. So we don't care. We don't need to know about this is delta or this is Y. If the same source, then current, we have current here, IA, IB, IC. They call IA, IB, and IC. So if the current is the same, this current is the same, same source, same current, then GY, G delta is the same. So we can transfer the delta to Y or Y to delta. This is a transformation. This is a viewpoint of the load. In the same way, we have some impedance. Then we have impedance in this manner. We have Y, this is an impedance. This manner here, and we have Y connection source and connect in this manner. Or we have same impedance, same load, but the source is has a different configuration. Like in this manner. So we have this is a source and this is a source, but the load is the same. Then also we have a current here. This is IA, IB, IC. So this is IA, IB, and IC. It's the same. This is the same. Then same load. In this case, the same current. So this is source Vy, V delta, then Vy equal to V delta. This is identical, it's delta and Y connections. So that means we can transfer the Y connection to the delta, and delta connection is Y. This is, we call this a transformation. So this is transformation. Then we need to find out what is a Y identical the structure, the Y and delta. So we'll drive there how to find it that. At first, I will introduce about in the case of the impedance. You find the Y connection at first. Here, 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 and we have define this is a terminal, this is a B, and this is a C. Okay, and cup here. This is the same, right? Then we replace this is another configuration in this manner. It's different color. Different color. So we define that variable is GA, and that variable GB, and that variable GC. And we have this variable define that variable is, we'll use that is G, actually we'll use another notation. This is a GAB, and G between CA and C. So we define this CA, and define, we name it as a GBC. The tension is a little different, okay? So if we have GA and GB and GC, and we need to find out the same characteristic of connection. So to do that, we need to find out the GAB, GBC, and GC. The notation is that this impedance is connected is A and B. So define then the name is GAB, and this impedance is connected between the A and C. So that is a GCA. And in the same way, this impedance is connected in B and C. So we define the name of that is a GBC. So our target is we need to find out the GAB, GCA, GBC to be identical with the Y connection GA, GB, and GC. So if two circuits is the same thing, then what's the meaning of that? That is to be identical each other. Then the line-to-line impedance should be identical. What's the meaning of that? That means if we connect in this manner A and C, and if we connect A and C in this manner, in the viewpoint of here, this line-to-line impedance should be same. The same way, if we connect in this manner here, then that impedance is like that should be same. If we connect this here, then impedance should be same. And we can say two configuration have the same impedance. So let's find out to define this impedance G ABY and this impedance G AB delta. And this this impedance we define G because connect up A and C, CAY, this is a G CA delta. And define this is a G ABY and G AB delta. And this is a G BCY and G BC delta. So this should be same. That means G ABY should be same as G AB delta. G BCY same as G BC delta. And G CAY should be G CA delta. Then we can say Y and delta identical. So this is the principle transformation, the Y and delta each other. So to find out at first, what is a GABY? GABY, I mean, this is ABY, their values. I mean, in the viewpoint of GABY, the C is open. So, because, I mean, in this case, we just see that this is A, B, A, B, C. We need to know, connect in this manner. So we don't care only these circuits. So we don't need to know about that. This is open. So in this viewpoint of that, that is same way. Difference. This is GA and GB. Therefore, this is GA plus GB. The same way, GBCY means we need to know it looks like that. So we don't care about that. In this case, we connect B and C in this manner. So this is opens. We don't care about GA. Therefore, GBCY is the same way GB plus GC. The same way GCAY is the same way that GC plus GA. And how about the delta? From the viewpoint of that, how about GAB delta? You know, the delta is a little bit complicated here. We define here. This is A, B, C. We define this name is a GAB. This is a GCA. This is a GBC. We will see that point here. Because we don't care only A and B terminals. So this is open, not connected here. Therefore, this impedance is the same with it looks like I don't know, one here, this is A and B, this is a GAB, and this is a three connected in this manner. So GCA and GBC in the viewpoint of the terminal A and B. So this is the parallel of GAB and sum of GCA plus GBC. Okay. Then if we calculate that, is result was GAB plus GBC plus GCA and GAB GCA plus GAB GBC. So in the same way, we can do this here, okay? Then what is a GBC delta? In the viewpoint of GBC, BC looks like in this manner. So this is open, so we can see that this and this path and this is connections. So there is a GBC parallel with GAB plus GCA. Then that can be written here as GAB plus GBC plus GCA. Then GBC GAB plus GBC GCA. So last we have GCA delta. In the viewpoint of that, GCA looks like that. So this is open, so we need to know that. So this is a parallel of that and these terms. So this is GCA parallel GAB plus GBC. So that result is the same manner. GAB, GBC, GCA, and GCA, GAB plus GCA, GBC. So to identical each other, to do that, GABY, that is same with GAB delta. It should be GAB delta. Therefore, GA plus GB should be same with GAB like Z plus GBC plus GCA and GAB GCA plus GAB GBC. In the same manner, GBCY should be the same with GBC delta. GBCY is GB plus GC. So that is GAB, GBC, GCA, and this here like that. So GBC, GAB plus GBC, GCA. And last, the GCA GCAY should be same as GCA delta. So GC plus GA should be same with GAB plus GBC plus GCA and GCA GAB plus GCA GBC. So we define this is equation number 1, equation number 2, number 3. So we simplify the 1 and 2 and equation 1 and 2 and 3. Then from yield, I mean the first equation number 1, GA plus GB was GAB plus GBC plus GCA. Then here GAB GBC plus GAB CA. And number 3, it was GC plus GA was GAB GBC GCA. Number 3 was that. That is it. That's number 3. GCA GAB plus GCA GBC. And number 2 was GB plus GC was GAB plus GBC plus GC BC GAB plus GBC GCA. From here, we replace is like that minus G. I'm sorry. Oh no. Replace. We move down is the manner minus GA. We move down is here minus GA, and that term is going here, and that term is going there. Then GAB plus GBC plus GCA and we have here we adding this term and this term. Then ABCA, we have 2 ABCA, so 2 GCAGAB plus GABGBC plus GCAGBC and minus 2 GA is the same with GAB GBC plus GCA GBC GAB plus GBC GCA. Right? So that value is 2GA is over here and the is there, then GAB plus GBC plus GCA and BCAB, ABBC, we eliminate, and CABC, CABC, we eliminate. So remaining thing is 2GCA, GAB. So remove that from here. We get GA is the same with GAB plus GBC plus GCA and GCAGAB. We like the orange because we need to sequence GAB, GCA. The same way, we can get the another three terms, GB. We can calculate the same way. Then the result was GAB plus GBC plus GCA. That is a GBC GCA. I'm sorry. Oh, no. The AB, G, BC. The GC is the same with GAB plus GBC plus GCA. So this is a GCA, G, oh no, let me use sequence. GBC, GCA. This is 4, 5, and 6. This is a transformation of NGA and GBGC from the delta connection GAB, GBC, GCA. So if the two circuit, I mean this circuit and this circuit is the same, then we need to transform the delta to the Y. Then we can use this relationship here. Okay. So if load is balanced, what's the meaning of that? That means GAB equals same with the GBC, Z with the GCA, the same value, G delta. Then we apply that here. So GA will be 3G delta and G delta square. Therefore, that is 1/3 G delta. The same way GB and GC. So if this is a balanced load, then GA equal GB equal GC. We define this as a GY. That will be 1/3 G delta. That means GY is G delta. case of the balanced. This equation show us the transform from the delta to y. This is a transformed delta to y. So we will get the levers. We want to get the case of y to delta case. No. And then how can do that? We use this relationship first here. We get these relationships. For example, can you use that here from 6? Then the GBC and GCA is the same with GC, GAB plus GBC plus GCA. To define this equation is number 7. And then you apply 7 to 5. Then GB is GAB, GBC, and GAB plus GBC plus GCA. This is because that is a distance, so this is a GBC, GCA, GC, and GAB and GBC. So we have a calculate that is more simple. GB is GBC, GCA, GAB, GBC, and GC. In this manner, so this is GCA, GAB, and GC. So we get it. The things like that. Here. Then, okay. Then, from 7 to 5, with the result is GB is GCA, GAB, GC. The same way, GC is GAB, GCA, GB. And we can do this is we apply the 7 to 5. The same way, we can do 7 to 4. So 7 to 4, Then 4 is GA was GAB plus GBC plus GCA and GAB GCA. So we apply that is GC GBC GCA and GAB GCA. Therefore GA is eliminate, GBC GAB GC. So GA is GBC GAB GC. Same way, GC will be GAB GBC and GA. All right. Therefore, from here we can rewrite the, we can use the GA and we use the 4. I mean, we will use this term here. Then GA is GAB plus GBC and GCA and GCA and GAB, right? GCA, GAB. Then from here, from these here, we get it. From here, GC is GAB, GCA, GB, and GAB will be GC, GB, GCA. The same way, GCA is GB, GC, GAB. So they can be replaced. And GCA is GB, GC, GAB square. Then GAB is a GAB. GBC can be the same way. The GBC mean from here, GAB, GBC is GA, GC, GAB. Therefore, there is a GA, GC, GAB, and plus GCA is the same things. GB, GCG, AB. So we can eliminate GAB, GAB, GB in this manner. Therefore, GA is 1 plus GA, GC plus GB, GC and GB, GC, GAB. Therefore, from here, we can calculate GAB is GCGB GB and GA 1 plus GAGC plus GBGC. Therefore, you can simplify that is GAGB and GAGB plus GBGC plus GCGA and GCGBGA. So eliminate, the result is GC GAB plus GBC plus GCA. We can summarize the same way, same manner. GAB is GC GA GB plus GBGC plus GC G over GC. GBC, in the case of that, is the same thing. GAGB plus GBGC plus GCGA is GA. Space here. Then GCA is the same things. GAGB plus GBGC plus GCGA and GB. This is a transform from the delta. I mean, in the express, this is y to delta. If balanced values, then GAB is balanced means A, B, C is same things. So this is 3GY squared is GY. Therefore, 3GY is G delta. Okay. This example, we'll solve the example. 12-4 and 1 is a convert the load into equivalent the Y connected load. I mean, it's quite complicated, but you can do this simply. The calculation is quite complicated, but the problem is simple. We have two loads here. There are two loads. This one is delta connections. Then you have another load. This is Y connection, this manner. So connection is like that. This is A. I mean, A is connected this manner. A phase like that, and this is B phase. And this is C phase. Like that. And A phase is connect in this manner onto that. It's A phase, and B phase is connected in this manner here, and C phase is connected in this manner. This is A and B and C. the problem is like that. The A is 30 plus J, and I will use the black ones. 30 plus J 40. And 40 plus J 40. And 30 plus J 3. And this is 80 plus J 80. This is 80 plus J 60. And this is 60 plus J 80. Then we need to make a one Y connected load in these configurations. So to do that, what should we do? At first to that, we need to think about how to combine two circuits. I mean, for example, if there are two Ys, then we have 1, 2, 3, 1, 2, 3, and this connect is in this manner, and connect in this manner, and connect in this manner. Then how can combine the two connection in two Y connections? If it's same thing as that, if from here we make this is the same with 1Y, then we need to make this as 1Y. What's the meaning of that? To do that, this and this is the same. What's the meaning of that? And when we point, we need to see the equivalent of this and this. The impedance should be set. For example, we define the for example in this view here, then it looks like this is a parallels and this is a parallel, and this parallel is the same with this parallel and this parallel. So it looks a little complicated because this parallel, I mean that series and that series. So that means we define this as for example the GY1. Okay, I'm sorry. This is we define GA1 and GB1 and GA2 and GB2, then GA3 and GB3. So two like that, I mean GA1 plus GB1 and parallel GA2 plus GB2. The same with GA3 plus GB3. It's very complicated. But if two delta case, then where's the delta? We have one here, one here, one here, one here, one here, one here. Then this is connect in this manner, and this is connect this manner, this connect in this manner. So we make one delta here. Like that. If the same things, that means this term and this term is the same. Now what should we do? We need to see this in dB point over here. For example, this line and this line. And we define the name of that is, we define this is a G. Simply we make a G to say the AB1, GBC1, GCA1, GAB2, GBC2, GCA2, and GAB3, GBC3, GCA3. In the viewpoint of that this, then this is open, right? So then it looks like that. In the viewpoint of here, looks like that is connected there, and also that is connected like that. That means we can rearrange that because this is common terms right here. This is common here, and this is common, right? That, and that is line here. This is common here. This is common here. So you can redraw like that. This is a GCA1, GCA2. This is a AB1, GAB2. This is a GBC1. This is a GBC2. So therefore, GAB3 is the same with that. This is only parallel GAB1 parallel GAB2. Same way GBC3, that is the same with this term. GBC1 parallel GBC2. GCA3, that is the same with only these terms. So GCA1 parallel GCA2. So when you combine 3-page load compared to the Y and Y and delta to delta is more simple. So when you combine these in delta and Y, in this case this is delta and this is Y. So we cannot combine these, the delta and Y directly. Then at first we need to transform this Y transform to the delta. Then there are two delta combined simply. Then the combined delta is transformed to the Y. That's a sequence. That's more simple. So summarize here is we have delta and Y in the manner. This is a problem. So at first we transform that is to delta. Then we combine this 1 delta. Okay. The main approach is we have 2 delta here and 1 delta and 1 Y, and we need to combine that is that. Then we'll transfer that is 1 delta and 1 delta in this manner, and combine that is single 1 delta. Then I can transfer this to 1 Y. So this is a way to prove this problem. So the first approach is Y load to delta load transformation. The Y load was This is A, this is a B, and this is a C. If you find the name of that is GAY and GBY, GCY. Let's name of that here. Then we can transfer. That is a delta, like that. This is A, this is a B, and this is a C. Let's define the name of that is GC delta, GB delta, GA delta. And the name of that is B is because this is B, so we define the name as B. The A, so we define the name of C is that. And the problem is GAY was 40 plus J 40. GBY was 30 plus J 40. And GCY was 30 plus J 3. So you know that. Actually, we know that G A delta was no, we will decide another name. You can choose another name. This is GBC delta. This is a GCA delta. Not sequence is ABC. So this is GCA delta. This is a GAB delta. Then GBC delta. We already know that. We already studied about that. What is that? GBC is use this equation. This is GBC. So you can use it. What is GBC? GBC was GAY plus GAY GBY plus GBY GCY plus GCY GAY. So we apply the variables like that here into there. Then calculate the result is 82.5 plus J 100. The same manner, we can do that. The GCA delta was 108.4 plus J 98.8, and GAB delta was 110 plus J 133.33. So we can transfer the Y. We can transfer the Y to delta. The impedance is in this manner. Then we do this. Then we reconfiguration. The connection of that is one delta and one delta here, connected in this manner, in this way, this way, in this way. In this case, this and this is parallel, this is this parallel, this is this parallel. So we rearrange here. Then we append this and yeah. Then we replace this term. We will replace this term is another delta. In this manner. So we define this is a G AB delta, because this is A, this is a B, and this is a C. So this is a GCA delta, and this is a BC delta. So we define the another name of that is, this is also GBC delta 2, and this is another GAB delta 2. This is a GCA delta 2. So we define this is a one deltas. So we redefine we transfer that is one single deltas. So we make one single delta like that. You define this is GAB delta EQ, GBC delta EQ, and GCA delta EQ. So now GAB delta EQ is a parallel of GAB delta and GAB delta 2. BC delta EQ is same with GBC delta and GBC delta 2 parallels. The same way GCA delta EQ is GCA delta parallel GCA delta 2. So we already know that the variables, we know that variables are here, and these variables we already calculate here in this manner, that variable is. So we apply that variables, and then that result can be simply the result was 4, 5 plus J 42 by 4, and 37, 78 plus J 44, 4. That is 46, 08 plus J 44, 25. Okay, then finally, then the last step is we can transfer that is we define this is A, B, and C. Then finally, we have to make the last Y connection configuration here. That is this is A, B, and C. So to define that is G A Y Q. This is a G B Y E Q. This is a G C Y E Q. You know, then we need to transfer the delta is to Y. Then we already know about that, because this is transformation from the delta to Y. So we get it. The G A Y E Q is we can use the equations here. I mean, you can use this. All right. Happy. Summarize here. Then A is same with GAB GAB delta EQ plus GBC delta EQ plus GCA delta EQ over GAB delta EQ and GCA GCA delta EQ. So that, and same way, GBYEQ is same. GAB delta EQ plus GBC delta EQ plus GCA delta EQ and GAB and GBC. I mean GCYEQ is the same. GAB the EQ plus GBC delta EQ plus GCA EQ and GBC delta EQ and GCA delta EQ. And because we already know about that all variables from here and apply that here, the result is 169A plus J 1428, and that is 1307 and J 1462, and there is 12.85 plus J 1509. So we transform the dahlias. I mean, this again can be replaced when you want Y. The result was here. This is a way to transform this is the make equivalent Y connection 3-phase load based on the Y delta transformation in this manner.